Welcome back. This lecture is the second part of the topic of power converters and their important role in the integration of all solar modules, components and loads in a PV system. During the last lecture you were able to understand the basic principles of how a rectifier works for the conversion from AC to DC. The learning objective of this video lecture is to understand the working principle of a AC to DC inverter and a DC-DC converter. We will start this lecture by understanding the principles of how an inverter works for the conversion from direct to alternating current. Power converters can contain uncontrollable semiconductor devices like the diode or controllable semiconductor devices like transistors and MOSFETs, which can be used as switches. Let's assume that switch S1 and switch S2 in the figure are controllable switches. Let's consider that the circuit shown has a constant DC voltage at the input. The figure on the right is the output voltage under the operation condition I will discuss now. If switch S1 is on and switch S2 is off, the circuit will conduct through the in green highlighted path. In this case, the magnitude and direction of the output voltage is equal to the half the magnitude with direction of the input voltage. This corresponds to time periods 1 and 3. If on the other hand switch S2 is on and switch S1 is off, the circuit will conduct through the in green highlighted path again. The magnitude of the output voltage is still the half of the magnitude of the input voltage, but the direction is opposite. This corresponds to the time period 2. When we look at the final output, we can see that the signal has a positive and a negative part and that it's periodic, even though this is far from a perfect sinusoidal wave. It resembles it. As I mentioned during the previous lecture, the topology of the circuit inside the power converter will define how close the signal will look to the idea, in this case a perfect sine wave. By using more semiconductor devices in more complex topologies, it's possible to obtain better outputs. Inverters are necessary when we want to connect a DC generation unit such as a photovoltaic panel to the AC distribution network. Without these power converters, the connection of the grid wouldn't be possible. Other distributed generation units that require an inverter for their connection are batteries or fuel cells, among others. The role of power electronic converters is not limited to aiding these AC to DC or DC to AC conversion, but is broader than that. Power converters also allow to adjust the output voltage so that a load can be connected. For example, a DC-DC converter is used to increase or decrease the output voltage with respect to the input voltage. A DC-DC converter uses transistors as switching elements. Let's have a look at the circuit. It will help you to understand the basic operation principles of a DC-DC converter. The transistor switches on and off, and as a consequence the output voltage is conformed of rectangular blocks as shown in black. The average output voltage will be V average equals T on over this time period, times the input voltage, where T on is the on time of the transistor. The ratio between the time when the switch is on and the complete period is called the duty cycle. The average output voltage is proportional to the duty cycle and can be deduced from the equation. Next week we will discuss that the charge controllers that manage the power exchange between PV panels and the battery include DC-DC converters. The last type of converters is the AC-AC power converter. This converter is used to convert an AC waveform into another AC waveform at a different voltage level or a different frequency without any intermediate DC conversions. The principles of operation of this converter is outside the scope of this course, but it was worth mentioning its purpose. In the last two video lectures, you have been introduced to the working principles of AC-DC rectifiers, DC-AC inverters and DC-DC converters. In this video lecture we focus on a simplified representation of a DC-AC and a DC-DC converter. Power converters devices are crucial elements for the integration of photovoltaic modules, components and loads into a PV system. In the next video we will discuss various topologies how DC-AC inverters can be used in various PV systems. So see you back in the next video.